So the next piece of this is great. We have asserted a user identity, but how do we now interact with the machines, the applications, the services that we want that maybe understand those identities or maybe don't understand those identities? And so when we talk about the traditional workflow for accessing these systems, it starts with a user who probably requests access to some private resource. This could be, let's say, an internal database that's running on our private network. So maybe they're a database administrator. They need access to that database to be able to perform routine operations. They are probably provided a set of credentials that allow them to get onto the private network to begin with. This could be VPN credentials, could be SSH keys, etc. Then they need to know the host names and IP addresses of the database so that once they're on the network, they know what to connect to. And lastly, they need a set of application-specific credentials, in this case, database username and password, to actually be able to interact with the endpoint system. And then their workflow kind of goes left to right. First, they have to log in to the VPN server or the SSH server using those credentials that they have. Next, they need to request access over the network to that private system using the host name or IPs that they know about. And then once they're connected to the database, then they would provide the application-specific credential, in this case, the database username and password, and then they'd be connected and they can interact and perform whatever operations they need. Now, there's a number of challenges with this traditional approach, and this ties back to Mitchell's earlier point around this transition we're going through from static-based systems to more dynamic environments. The first one is around how do we think about onboarding of new users, right? For every new user, do we need to distribute a set of new SSH keys, VPN credentials, database credentials, etc.? What about when that user leaves? What about having to do periodic password rotation or credential rotation, right? So you can start to see how this onboarding process becomes cumbersome at scale. The next piece is the user is connecting directly to a VPN or directly to an SSH bastion host, and that in effect brings the user onto our private network, right? And so while that has its advantage in that the user can now connect to these resources that are on the private network, it also has a disadvantage, which is the user can connect to all sorts of things that are on our private network, right? We don't necessarily want the user directly on the private network. So as a result, because the user should really only have access to a handful of systems, we typically would deploy a firewall in between the VPN and the target systems, or in between the SSH bastion and the target systems. But that that firewall operates at an IP level, right? There's a set of IP controls that constrain which set of users or which set of IPs have access to which set of IPs. And the challenge with this IP-based approach is that it's brittle, right? It works great in a very static environment, but the moment we have endpoints that are auto-scaling up and down, we're deploying new services, maybe we're running on Kubernetes where if a node dies, the application gets moved to a different node on a different IP address. And so in these very dynamic environments, we have a challenge of keeping these IP rules, these IP controls up to date, right? So it becomes very brittle as our environment gets more and more dynamic. And then the last piece of this is the user actually has to have those endpoint credentials, the database username and password in this case, to connect to the target machine. And so what this means is we're disclosing it to the user. That user could potentially leak it, could leave it on a passwords.txt on their desktop, post it into Slack, etc. And so we create an additional risk that those credentials get exposed. So a different way of thinking about this is to use identity as the core primitive, right? And where this would start is the user, again, logs in with their trusted form of identity. They don't use a specific set of VPN credentials or SSH keys that were distributed to them. Rather, they use their same single sign-on and use that one point of identity that they already have that the user is onboarded when they start. Next is ideally we would just select the system we want to connect to from a set of existing hosts or services in a catalog. We wouldn't want to know a set of DNS names or host names or IP addresses in advance that may or may not change, right? We'd rather just look at a dynamic catalog that shows us what we have access to, right? The next piece is we want the controls of what we have access to not be at that IP level where it's dynamic, but rather at a logical level where it's service to service. I want my database administrators to have access to my set of databases regardless of what the IP of those databases actually is, right? And then lastly, we want the connection to happen automatically to the endpoint service without having to give the user necessarily the credentials underneath the hood. And so this has a number of advantages if we can do this. One is that onboarding and offboarding is dramatically simplified. We don't need to distribute a bunch of specific credentials. We don't need a rotation workflow. We don't need to offboard that user. We add them to our IDP, our identity provider, and then we remove them from our identity provider, and everything is linked to that. Next is because we're just selecting a host from the service catalog, we don't actually need to give users direct access to the network, right? They don't need to know what the internal IP address is. They don't need to be on that private network because really they just care about the target host, the target service that they're trying to get access to. The advantage of moving the rules up from sort of an IP level to a logical service space level is it's much less brittle. Now we can put those services in an auto-scaling group, scale them up and down. We can have them on a node, do a failover and move the app to a different node. We can deploy net new services. And we don't have to worry about changing our controls all the time to keep pace. And then lastly, because we're not distributing the credentials to the user themselves, they don't necessarily have the database username and password. When they connect automatically, they're authenticated against the database, and they've never seen the database credential, right? Making it that much harder to expose it or cause an additional data leak. And so how do we make this workflow real? How do we move towards this identity-based model rather than the more static traditional workflow? Today, I'm very, very excited to announce a brand new project called HashiCorp Boundary. It's free, it's open source, and I want to spend a little bit of time today diving into what it is and how it works. At the very highest level, Boundary is trying to provide the workflow that we just talked about, really focused on that identity-centric workflow for how do we authenticate and authorize access to systems. So where this starts, as you would guess, is with a user who's trying to access an endpoint system, right? The first thing that user is going to do is authenticate themselves through one of these trusted forms of identity. So Boundary makes this a highly pluggable thing, so whether that identity is being provided by Okta, by Ping, by ADFS, by Active Directory, doesn't really matter. There's a pluggable provider, much like Vault, that allows that identity to be bridged in from whatever existing IDP you have. Next is once the user is in, we have a logical-based set of authorizations in terms of what that user can access, right? So great, we might map that user into the group of database administrators. We'll say database administrators have access to a set of databases. The notion of what a set of databases is dynamically maintained in a catalog. That catalog can be programmatically updated using a Terraform provider. It could be kept in sync by integration with Console, where we're querying Console's view and service registry of what services are where. But it can also be integrated into other service catalogs, such as Kubernetes or AWS or cloud APIs, right? These other systems have a notion of these services and ability to tag them or add different selectors. And so being able to import those and reference those in a dynamic way, rather than have to deal with static IPs, makes this much, much simpler to manage. And then lastly, when the user actually goes to connect, we don't want to provide the credential where we can. And so we can integrate with a system like Vault to provide the credential dynamically just in time. So in certain cases, we have no choice. We might have to provide the user with a static credential. But in cases where we can use Vault's dynamic secret capability, how do we generate a credential unique to that session that's short-lived and time-bounded? So the user can connect to the database with a unique credential just for that session that they never even see. And at the end of their session, that credential can be revoked and cleaned up and isn't a long-lived static credential that we have to think about and manage. And so the goals of Boundary are really fourfold. One is how do we do this on-demand access that's simple and secure, right? We don't want you to have to do a whole lot of pre-configuration and pre-setup. We want it to be very much push button and on-demand. Two is we acknowledge the world is becoming much more dynamic, much more ephemeral. So how do we support that, right? And that's really around a few of these different pieces, making the system very API-driven and programmatic, integration with dynamic service catalogs, integration with dynamic secrets, and really leaning into this notion that we don't want to manage static IPs because our world doesn't consist of static IPs, right? The other piece is making the system easy to use, right? We want it to be user-friendly because not only do you have administrators who are configuring it and maybe understand the system in depth, but you have end users who don't really care how it works. They just want to have access to these endpoint systems, and we want it as easy to use as possible. And lastly, it's free and open source. What we've seen time and time again with HashiCorp is the best way to make these products successful is to build thriving communities on top and around them. And so we're excited to do exactly that with Boundary as well. So here's a screenshot where you can see Boundary's UI. And what you'll see right away is 4 different boxes that describe logical services that we might want to connect to, right? You'll notice we're not talking about IPs, we're not talking about a low-level host. It's this bucket of high-level services in the environment they're running in that we want to be able to connect to. And again, this ties back to the 3 aims, which is identity-based access and control. Nothing is IP-driven, nothing is host-driven, right? 2 is we want an automated access workflow, right? We want this to be able to be API-driven, to integrate it into our scripting environments, CLIs, automation tools, CI/CD pipelines, etc. So there's a rich API that allows all of this to be automated. And then lastly, how do we really have first-class session management, visibility, and auditability of what's taking place? If we have privileged users accessing sensitive systems, we want to have full visibility of when and where that took place, and to be able to have that type of insight, whether for security or compliance reasons. And of course, you know this is designed for practitioners because we also have a black mode, dark mode UI that's visible here as well. So here's a different example of interacting, which is really what we expect the day-to-day to be like, right? If I'm a Boundary end user, I'm not an administrator, I'm just trying to SSH into a target machine, right? How can we make this dead simple? And here's how simple it can really be. It's a single command. It's boundary, connect, SSH, and the target that we're trying to get to. And you can see that we are dropped right into a shell, right? And that's really the goal. Behind the scenes, there's a whole lot of machinery that's making this possible, right? Our SSH client that's running locally is talking to a local agent that's spun up as part of this command, right? As part of Boundary Connect. That agent is doing the authentication for us against the gateway for Boundary, and then establishing a connection to the Boundary gateway. The Boundary gateway is then authenticating and authorizing us, and then connecting back to the endpoint system. And so now we have an end-to-end connection going from our machine to the gateway to the target environment. But to the degree possible, all of this is automated and invisible to the user, right? They can continue to use whatever local tools they're comfortable with. Use your local SSH tool, use pSQL, use whatever local tooling, and you're always just talking to a local agent that's proxying all the traffic back. Very similar to how SSH port forwarding would work. And so we're very, very excited about Boundary. Today is the launch of the product and the 0.1. It's available. Please go check it out at boundaryproject.io. It's also on our GitHub page, so if you find issues, give us that feedback and engage with us. We're super excited, and there's going to be more content on Boundary later in the day.